Question 1a. Given that 7 minus 2s, 9, 5s plus 17 are consecutive terms of a geometric progression GP with common ratio arrow is greater than 0. Find the value of s. Solution. In geometric progression, the common ratio can be obtained by dividing second term by first term and is equal to third term over second term and is equal to fourth term over third term and so on. So you have second term over first term equal to third term over second term. If you cross multiply, you have this result. Now let's expand the right hand side. So 7 times 5s, 35s. 7 times plus 17, that is plus 119, minus 2s times 5s minus 10s squared minus 2s times plus 17 minus 34s. If you add like terms, you have this result. Already, the presence of s squared suggests that what we have is quadratic. So let us transfer all the terms to the left hand side so that the coefficient of s squared can be positive. So you have 10s squared, you transfer this plus s, you have minus s. Already plus 81 is there, you transfer plus 119, you have minus 119 equal to 0. If you add the two constants, you have 10s squared minus s minus 38 equal to 0. I want to solve using quadratic formula, and the formula is this. By comparison, a is equal to 10, coefficient of s squared. B is minus 1, coefficient of s. C is minus 38, the constant term. So you replace them in the formula. If you simplify, you have these results. Minus 1 is plus 1. You have plus minus 1 squared is plus 1. Now this minus times minus is plus. So 4 times 10 times 38. You have 1,520. If you add under the root, you have this result. If you check the square root of 1521, you have 39. Because of this plus minus, you write this expression twice, starting with minus. So you have 1 minus 39 over 20, or 1 plus 39 over 20. If you subtract and add, you have this result. If you reduce, you have minus 19 over 10, or 2 as the value of s. Question 1b. Two positive numbers are in the ratio 3:4. The sum of the thrice the first number and twice the second is 68. Find the smaller number. Solution. Let the two positive numbers be m and n from the first statement in the question. Now m ratio n is equal to 3:4. If you express the ratio as fractions, you have m over n equal to 3/4. Let's express m in terms of n. So you have m equal to 3/4n. So let's call this equation 1. From the second statement, if you multiply the first number by 3, that is 3m. You add it to twice the second number, 2n, the result is 68. This is what you have here. You call that equation 2. To solve for m and n, you have to replace m in equation 2 by equation 1. So this is equation 2. Anywhere you see m, you replace it with equation 1. That is 3 over 4 n times n. You have it in this form. If you open the bracket, you have 9 over 4n plus 2n equal to 68. You can multiply through by 4 to clear the fraction, and you have 9n plus 8n equal to 272. That is 68 times 4 times 4. If you add the common terms, you have 70n equal to 272. Divide through by 17, n is equal to 16. Now that you know n, you can easily get m using equation 1. Equation 1, m is equal to 3 over 4 n, and n is 16. So you have 3 over 4 times 16. That is 3 times 4 equal to 12. Therefore, the two positive numbers are 12 and 16. The smaller number is 12.